I am. Yeah.
Yeah,
I'm a
I
South Shore
spent.
person, but I have
Okay.
a good friend out here that grew up in Marblehead, so right in
Yes,
that. And I have a
very
brother that
nice.
lives in Georgetown, right next to Newburyport.
Yeah, very nice. I spent many a summer in Gloucester, so I love hearing. So just to kick things off, Dr. Kelly, I'm very excited. First of all, Chase proposed having you on the show. I'm incredibly interested in this whole concept of senescent or zombie cells. Certainly, mitochondria and cellular rejuvenation have always been areas of interest of mine, especially with my mom. I don't know how much you've read about Well and Strong, but I started this platform about 4 years ago, essentially because my mom was diagnosed with stage 4 breast cancer in 2018. She had a recurrence, and I just did a lot of dove into the world of integrative medicine when it came to different complementary cancer treatments. So Well and Strong started off as a platform for me to share that research, and then just grew from there, you could say. So yeah, I mean, this is an area where I'm very interested in. Certainly would love to get into Qualia Senolytics and the science behind that. But just to start off with the basics, Dr. Kelly, let's go
Sure.
kindergarten level here. For
Yeah.
listeners who never heard of the term cellular senescence before, what is it, and why should we care about it?
Yeah. So the way I think of cellular senescence is first and foremost, it would be a cellular stress response. So when cells are stressed, and this oversimplifies it, but it's pretty like a useful way to think about it. If they have the resources available, then they'll toughen themselves up. So they get a little bit of stress, they become fitter, smarter, more resilient, however you want to term it. And they do that by upregulating things like antioxidant defenses and other molecules. But now imagine stress is even more than that. And so when that happens, maybe they'll take on some damage, right? So that's where usually things like, proteins get a little bit misfolded, or DNA may be damaged. And what cells then try to do is repair the damage. So I know you would know of autophagy, or the mitochondrial equivalent mitophagy, or DNA repair process. That's when those things come in, right? The cells took on some damage, but they're fundamentally still repairable. And
Right.
what a senescent cell is one that's been so stressed for some reason that it's no longer repairable. And when that happens, there's certain things that can get enacted so that the cell won't copy itself, because we don't want really damaged cells making copy after copy after copy. That
Right.
wouldn't be good. So what would happen in a young person when a cell becomes that stressed and senescent is that shortly after, either the cell automatically goes through what's called apoptosis, but that's a Greek word that translates something like falling off. So for listeners, think of like a fruit or a leaf falling off a plant, like that. The end stage for really stressed cells should be that apoptosis process. And what apoptosis would look like under a microscope is a cell would just break apart into little pieces, and then the immune system would gobble up that and recycle
Mhm.
it. So what happens, and why we care about cellular senescence, and what we'll talk more about as zombie cells as we get older, is these cells have figured out a way to resist going through that falling off process. So they linger. So like imagine now you're looking at a plant, and instead of the yellow leaf or fruit falling off, they just stay stuck there. And
Right.
over time, as that accumulates, that tree or bush or plant is going to really struggle to do its
Of
job.
course.
And that's what fundamentally happens with us as we get older. More and more of these senescent cells linger in our tissues, and they can cause all kinds of issues for us. Many of the
Yeah.
things we think of older age, like our skin, our muscles, our bone health, joint health, you name it, all of those things have some correlation to the accumulation of these senescent cells. So
Right.
because of that, this area called cellular senescence is now thought of as one of the core, what are described as hallmarks of aging.
Interesting. And you keep mentioning aging, Dr. Kelly, but I mean, is that the primary factor that determines whether a cell goes through apoptosis or becomes a senescent cell? Like how does, like, what determines that?
Yeah. So just like our whole body, our cells, are born, live their healthy life, and die. And if you Googled it, you'd see something like cells have an average lifespan of about 7 years. And
Hmm.
that's true, but misleading in a sense. What's more accurate is that the length of the lifespan of a cell varies tremendously depending on what tissue that cell happens to be in, right? So neurons, our brain cells, those are meant to last a lifetime. We don't make new ones. Whatever you and I have today, those ones hopefully will carry through to the rest of our days. Cells in the heart, I think it's about 4 decades is their lifespan. In muscle tissue, it's about 15 years. But some cells, like those in our liver, are really short lifespans, like 1 to 2 years. And so
skin.
Skin's also, because we slough off skin, right, on a constant basis. So things that interact with the environment, like, the cells that line our digestive tract also have really fast lifespans. So it's completely normal that we would give birth to, and then cells would fundamentally get old and then die off and be replaced. And so that word I used, apoptosis, is a normal process. I don't remember the exact number, but tens and tens of millions of cells are going through that every day. And what the issue is with the senescent cells is they're just resisting that natural process. That fun, I guess, like a way to think about it is there's lots of things that can cause cells to become stressed, right? Toxicity, nutritional issues, environmental things like the sun, as an example with our skin. And so it's, again, natural that cells should be stressed, and then they should respond in one of those ways that I mentioned, right? Toughen up, repair the damage, or if they get too stressed, then, go away and be replaced by new, vital, young, healthy cells that can now do their job better. And it's always been thought of that senescent cells had some connection to aging, since you mentioned aging, and that's in their name. So just like the word senile, the root for senescence is the same, right? It has to do with this idea of aging. But it's only really been, say, about the last 15 to 20 years that scientists started discovering how big a role. And what they've found is one of the reasons is, and the way we think of it at Qualia, is that there's transient senescent cells and lingering ones. So imagine, if one of the listeners on the show is 20, 25 years old, or, has friends, family that are young, if they went out and ran a marathon, they'd make some senescent cells. Completely normal, right? They just stressed out their body, even if they were in shape for that. But what you would see in a young person or a young animal is within days to a week after, those senescent cells would have been removed. They would have been transient. They'd come in as a wave, kind of did some repair things. Senescent cells tend to call the immune system into the tissue. And then, once they've done their job, they're cleaned up by the immune system. And what happens if you were to say, now look at an old animal that did an intense amount of exercise, there'd be an explosion of senescent cells. So they would make way, way more. And then if you looked a week, 2 weeks, a month later, they would still be lingering in the tissue. And so that's the key idea with aging, isn't that senescent cells, writ large are bad. It's that they linger, and that lingering process occurs because they resist falling off the plant, so to speak, right? They resist.
Interesting. What's considered the age cutoff for that? So I'm 29.
Yeah. So there's no, the field of senescent cells and cellular senescence is fairly old, but senescent cells are really hard to measure. So to do them adequately, it's not like you could look at a marker in the blood, like, cholesterol for risk for heart disease, as an example.
Right.
For senescent cells, first a scientist really needs to know what they're looking at, and then they'll take tissue biopsies, and there's several different markers they'll check to verify that it's a senescent cell. So because that studying senescent cells is, one, it's hard, and two, it used to be thought that there was nothing that could be done about senescent cells. And so we'll get a little bit more into what you can do a little bit later. But because of that, there wasn't a lot of research until, I would say, about 2015. The field's really taken off in terms of the amount of research. So getting back to your answer, like what age, the main thing we would know is that over time, whether they're, animals being researched to advance the field or humans, we accumulate more, but we do it unevenly, meaning that some people will accumulate more maybe in their muscle tissue, other people maybe more in their fat tissue, other people maybe more in their joints. And that, like many things with our body, it tends to be a tipping point of sorts, right? So allergies is a good example. Most of us, even if we don't have allergies, if we were exposed to a whopping dose of some tree pollen, we would probably experience allergic symptoms, right? But on a normal basis, we're just below our threshold where that thing's an issue. And senescent cells are thought to be that. So, 29-year-old, you probably have relatively few. Like, I'm assuming you would have like an age appropriate amount, which would likely be below the threshold to notice them symptom wise in any of your tissues. Mm-hmm. Someone that's 40 may, in one tissue, we'll just say joints as an example, may now be past the tipping point there, but in every other tissue, maybe they're below it. So they're starting to have, some joint discomfort, maybe that's showing up mostly if they exercise a bit more than they're useful. Someone that's my age in their early 60s likely has, like a much bigger burden in multiple tissues, some of which may or may not be beyond that tipping point. And so the key idea that we use at Qualia is to think of a gardener. So we'll go back to our, yellowing plant analogy. So what would normally happen ideally on a plant is you get a yellow leaf and then it falls off, right? Like it's not getting good nutrition for whatever reason, and it just naturally gets shed. But sometimes that doesn't happen. And so good gardeners, watch their plants and then periodically prune off leaves that aren't, as healthy as the other ones. And so one of the things that I believe is that, and we'll just step back to give the frame of reference. So we all would be familiar with the idea of an average person, maybe a man right now lives to 76, a woman to 78. It usually skews a few years higher for women. So that average is, again, a little misleading. I think a more useful thing is how long would someone live on average if they make it to age 60? So that would be what's thought of as life expectancy at 60. And that's, of course, higher, right? Because we've lost all the younger people that died in car crashes and for other reasons. And in North America, that's about 83 years. So so more, right? And then how much of that time is healthy? And what in the newest study, which was about 2019, I think, when it was published, it was about 1/3 of that was experienced in really poor health. So disabled, in assisted living, something along those lines, right? Wow. So the goal is, first and foremost in medicine, I think, is closing that gap, right? So that we experience more of that life expectancy after 60 is healthy life expectancy. And the way I think about, okay, well, how do you do that? And, having been a practicing naturopath at one point, I can assure you it's a lot harder to deal with issues after they occur with our health than to prevent them from occurring in the first place. So long story short, the way I think about it is if I want to have a different result than my dad or my mom or their parents, I have to do more things earlier than they had done. And often quite different things, right? They didn't know many of the things that you and I would know and that your audience and our listeners today would know. So the goal would be for someone, say your age, 29, is maybe, senescent cells aren't a problem, but long before they start to become a problem, maybe I want to start to be a good gardener and prune them away, if that makes sense.
Yeah, no, absolutely. I want to get into how we actually prune them away. But before that, one thing that came to mind that I'm really curious of your thoughts on, I'm sure you've heard of True Diagnostic.
Yeah.
Right. So what are your thoughts on that? One of their tests, it basically tells you the rate at which your internal organs are aging. I'm curious, does that take into account senescent cells? I know you said there's no way to actually measure them aside from doing a tissue biopsy, but from that one small, drop of blood that we give for that test, I'm just curious, are there any mechanisms that, in which senescent cells play a role into determining that quote unquote true biological age?
Yeah. So the person at my contact at True Diagnostics is Ryan Smith. He was one of the founders of it. And so I've known him since, 2019, probably a good chunk of time. And So early on, when Qualia was developing our Senolytic product, I wanted a way that we could maybe measure to see, like, all right, is this making people healthier? So I got him on the phone. I'm like, oh, like, do any of your tests, would these work? And he's like, no, they don't. And at the time, what they were doing is some of their team and some of the people they know, some functional medicine MDs, were taking some of the Senolytics and measuring before and after, and they just weren't seeing a pattern. And they eventually did a bigger study and wrote it up. I think it was published around August of 2023. But there's a variety of reasons they don't. But one is, think of what those tests are measuring is DNA methylation. Fundamentally, that's what it's called, on healthy cells. And senescent cells are just their own category of cells. So what's happening on them isn't necessarily translatable to what those tests are measured. So far, those tests aren't particularly useful for assessing senescent load. Now, they're picking up something, clearly. And, my guess would be, given enough time, maybe you'd start to see something showing up on the DNA methylation patterns in healthier cells. But over like a 6-month period, which I think was their initial trial period, there was nothing. And the originator of those, they're called aging clocks, and the pace of aging would be a 3rd generation clock compared to one that would have given you, or prediction of your biological age would be a 1st or 2nd generation. And Horvath was the founder of the original algorithms and idea. And I want to say around 2020, he had even written that these things just aren't the same, that senescent cells and DNA methylation wouldn't be expected to be a useful measure. So that's still an issue in the field of cellular senescence, is figuring out a way to measure them less directly than a biopsy, because most of us don't want to sign up for that.
Right. Yeah, it's fascinating, all of the testing that's coming out. I had Dr. Matthew Dawson on the show not too long ago, founder of Wild Health. I'm sure you're familiar with him as well. And he's doing some really cool things with AI. So it's really exciting to even just see what the next 10 or 20 years will hold in terms of testing.
I spoke to him recently as well, really. And I think he's currently acting as the chief medical officer for True Diagnostics.
Yep. Very cool. Awesome. Well, going back to the main meat of the conversation, Dr. Kelly. So what can we do to, quote unquote, prune our garden and get rid of these senescent cells? Yeah.
So one of the huge advances in cellular senescence in that field was around 2009 or 2010, where they did what's called a transgene, but I'm oversimplifying it, but just think of, they genetically modified these animals so that their system would get rid of senescent cells instead of them lingering and accumulating over time. And what they saw in these animals was that they lived longer and they were way healthier. So, glowing fur, leaner bodies, less joint issues, you name it. And, so again, we can't do that experiment on humans, right? We can't genetically modify us. But at the time, that really caught some scientists' eye, because all of a sudden it was like, oh, these might be even more important than we thought, because if we manage them better as we age, good things seem to happen. And so in 2015, some scientists from Mayo Clinic and Scripps Institute of Aging, which there's a Scripps here in San Diego where I live, but that Institute of Aging one is on the East Coast in Florida. They got together and thought, okay, well, what are these zombie cells, these senescent cells, doing to resist apoptosis, just from a mechanism perspective? Like what pathways and other things are they using? And they started figuring that out. They call those SCAP networks, so SCAP for listeners, which stands for senescent cell anti-apoptotic pathways. But just think simply like the scientists figured out, okay, this is how they're staying glued to the plant and not falling off. And then they scanned their long list of compounds that had some science on them about that mechanism. So things that were active on those pathways. And at the end of that result, then this was on a test tube. They then took some of the compounds that look like they should overcome those mechanisms and applied them to senescent cells. And 2 of them at the time would then cause the senescent cells to finally, what I would say, recapitulate that journey to apoptosis, right? Like get out of this stuck place and finally go through this falling off process they should have gone through. And those compounds were dasatinib, which is an immunomodulator, often used in some very specific types of cancer. That's and quercetin, which is a bioflavonoid or flavonoid compound, polyphenol that's concentrates in the skin of onions as one example, right? And what they found in that study was then, okay, well, these look promising in a cell culture, but let's now give these to animals and see what happens in the older animals. And what they found was that dasatinib, as an example, was active in some tissues. So fat tissue was one to help prune away senescent cells, but not as active in others. And quercetin was active like in endothelial, which is the cells that line our arteries, as an example, but not active in fat tissue. So then they thought, oh, cool. Okay, cool. Maybe we should just give these together, stack them, and see what happens. And lo and behold, the 2 together work better than either on their own. And at that point, they're like, okay, we need to come up with a name for these things that, help senescent cells finally normalize and complete their journey. And we'll just call these senolytics. And so in that paper, they launched that term, senolytic. And so a senolytic would be something, in a strict definition, that would be used to get a senescent cell unstuck and to finally complete that journey. And since then the field has extensively looked at that combination of dasatinib and quercetin. There's more papers on that than probably, all the rest of the senolytic compounds put together. But other scientists have also looked to see, well, okay, if quercetin did it, maybe there's other things in plants that are also senolytic. And so that's the what do you do? A part of that what do you do would be doing things that are called senolytics.
Very cool. So what is Qualia? What are the main compounds in the Qualia Senolytic?
Yeah, so Qualia is our brand, and Qualia Senolytic is our stack of compounds. And the reason stacking becomes important, I think, is that original Mayo concept or Mayo finding that something could be senolytic, but that doesn't mean it's going to get rid of senescent cells in all tissues. That and stepping back, I mentioned that senescent cells, can be thought of as something that are caused by stress of all types. So what it looks like is different stressors can cause slightly different varieties of a senescent cell. So for listeners, think of senescent cells as a category within that of things that all share the same basic, like you'd be able to find them if you know what you're looking for. But if say UV light caused senescent cells in your skin and something else caused senescent cells in your fat tissue, the same senolytic compound may not equally work on both of them. Senescent cells in joints may be a little different than the ones in fat tissue. So what Qualia Senolytic is we put together 9 different senolytic compounds, some of which have been studied. And again, for listeners, almost all of this research is still in animals. The human studies are just starting to be published or are in their recruitment to execution phase. Right. But for mechanisms, what science invariably has to use is starting in vitro, in cell cultures, and then in animals. And so as an example, fisetin was the next big senolytic compound that those same Mayo and Scripps researchers published about. And what they did was, this was a couple of years after the 2015 paper, they said, okay, well, if quercetin worked, let's gather some other polyphenol compounds from plants and see, again, in test tube, applying them to senescent cells, if any of those work as well. And what they found is one that sometimes you'll hear it called fisetin, sometimes fisetin, but that one was even stronger than the quercetin. They also found one called luteolin, which was more active than quercetin, and curcumin, which was about the same. And curcumin, I'm sure a lot of listeners would know of or use turmeric or turmeric extracts with curcumin. And so then with fisetin, all right, this was the strongest in the test tube. So step 2, let's give these to animals and see what happens. And that one was actually, again, really active in animals, and it was more globally active than quercetin. So like in that study, one of the places it was active was in fat tissue, where I had mentioned in their original research, quercetin wasn't. So, from my perspective, that original insight, right, that stacking things together might be useful is my bias, especially with the plant compounds, of how we want to approach it. So like fisetin is good, and maybe more globally senolytic than quercetin, but quercetin, we know has activity in certain things. So why not do the two together? And then the next big advance was, and this actually was published before the fisetin study. There's an Ayurveda plant called long pepper. So there's a really famous, it's called trikatu, but like it's a blend, tree like tricycle for three, of three, what are called the three spices, or the three pungent compounds, I guess would be the more literal translation. And it's black pepper, long pepper, and ginger that are used in a lot of Ayurveda preparations. And we don't use long pepper here, but it would be very similar to black pepper. Like it's a pungent thing, it's a spice, it's very close relative. But long pepper has something called piperlongamine in it that black pepper doesn't. And so what this other group of researchers, not Mayo anymore, found was that piperlongamine was also senolytic, but it was in a completely different way. So the things I mentioned, the quercetins, the fisetins, the luteolin, all work at least in part on a nutrient sensing pathway. So cells, so our senses for listeners are things like our vision, our hearing, right? We're constantly sampling the environment and deciding how to behave. And so cells are doing the same thing. They sample the environment through receptors and nutrient sensing pathways and then determine how to behave. So that's where when we say something like calorie restriction or mTOR would be something that you talk. Yeah, so mTOR is a specific nutrient sensing pathway. Protein, right, is what it's listening for. And so what cells do is they listen to the environment around them, and when it changes, then they change their behavior. And sometimes that behavior will change in ways that will say, oh, well, the environment's not looking so great, so I better make sure I prioritize repairing myself so that I'll make it through this tougher period of time. And so the quercetins, the fisetins, they all work on a specific nutrient sensing pathway in part. And piperlongamine works in a completely different part of the cell. And so, again, like one of the ways I think about it, and at Qualia we think about it, is we want to be redundant in how we approach an issue and support it from multiple angles. And so, piperlongamine starts to make sense. So, so that's when we approached making Qualia Senolytic, that's how we approached it. Let's find, a variety of these compounds that in at least the existing studies have been active in different tissues, ones that, have redundancy in terms of, a pathway, but also redundancy in terms of, non-shared mechanisms.
So fascinating. For someone with no medical background, I would have loved to sit in on those discussions in terms of figuring out what compounds to include in Qualia Senolytics, but so fascinating. My other question for you, Dr. Kelly, is what compound targets senescent cells in the brain? And would you say that the brain tissue is perhaps like, I don't know, of all the organs of all the places in the body where senescent cells accumulate, like what would you consider to be the most dangerous, let's say?
Yeah, so those are good questions. So, so in the brain, there's different types of cells. So neurons would be, like the archetype of what we think of as a brain cell. But then there's all kinds of supporting cells. So the brain has its own immune system. Those are called microglia. It has structural cells, which are other types of glial cells. And it was originally thought when the field of senescent cells was younger, that the only cells that could become senescent were cells that could create offspring cells so whether you call them like clones or daughter cells, like our cells can divide, right? And so the same genes would then be passed into those lineages of cells. And so cells that can't divide. So stepping back, one of the reasons early on that it was believed that we had this senescence software program was that we don't want a damaged cell to make copies of itself and then have that damage ripple through time, and that cellular senescence was an anti-cancer function fundamentally, right? Because, and that if a cell wasn't ever going to divide, like a neuron, I mentioned earlier that the neurons that we have never make copies of themselves, right? We want to make sure the goal with those is to keep them repaired, right? Or low stressed in the first place. But now in the last, say, 7 or 8 years, like scientists have found that even a neuron can become senescent, which that wasn't even thought as possible at one point in science.
Really? Is that one of the primary leaders or contributors to dementia?
It would be more. So I haven't mentioned it, but you've touched on the zombie cell a few times. So the reason that sometimes you'll hear senescent cells referred to as zombie cells is in part because this being stuck, right? They're not quote, quote, alive, right? They can't make offspring cells anymore, but they haven't gone through apoptosis. So they haven't gone through cellular death. They're somewhere in the middle, like a zombie would be.
Could they be reactivated though? Like once they're in that zombie state?
You mean turn back into like a healthy cell?
No, like turn like more of like an active like.
Well, they're metabolically active, right? They're still using resources, and they're actually using a lot of resources. And the reason is the other part of the zombie story. So senescent cells will secrete into the microenvironment surrounding them a variety of compounds. And these are things called chemokines and cytokines. But just think of the word inflammation, that they're things that in a young person would call the immune system in after, say, like a lot of exercise to clean up, and help repair. But in the lingering ones, it contributes to what is called inflammaging, right? That chronic low-grade inflammation that happens. So the net result of them secreting these things to, in around themselves and impacting other cells is that they can stress out other cells and cause them to become senescent, right? So that's the other piece of the zombie analogy. And that's a big reason that they're so significant as we age, because they contribute to both inflammation locally in their environment, but then systemically throughout our body. So getting back to your question, it's the other ones, like, so neurons can become senescent, but it's unlikely to be a main issue, right? Just because they're not designed to replicate, right? So they would have to be a lot bigger stress for them to become senescent. But all the other things in the brain that are the supporting cells for neurons can, right? So the microglia. And inflammation contributes to bad things wherever it is, if it's a chronic inflammation. Right. So, whether it's, like a mood issue, anxiety or depression as an example, or an issue with the brain and aging, like a dementia, that inflammation is always at least a piece of that.
Right. So. Very interesting. So beyond stacking compounds for Qualia Senolytic, what are some lifestyle interventions that listeners can stack perhaps in conjunction with taking Qualia Senolytic? So you mentioned caloric restriction before. I actually had someone yesterday on the show to discuss intermittent fasting, but I'm assuming exercise and also too, Dr. Kelly, you've mentioned stress a lot as a cause for senescence, but I've also heard of the term hormetic stress, right? And things like hormetic stressors like saunas, for example, that, might actually help like promote autophagy through, heat shock proteins, and, how that could also like clear out damaged cellular components. So what are your thoughts on those?
Yeah. So exercise, we'll start there if that's okay. So
absolutely.
Exercise has been studied to see what it does for senescent cells. And going back, I mentioned that, in a young animal post, some intense exercise, especially if they're not used to it, they'll make senescent cells. They're transient. They'll call the immune system in, they help repair, and then the senescent cells are cleaned out. And that older animals make a lot more, and that they tend to linger, right? So that there's that connection to exercise. But what's also true is that, when they've looked at what would be more exercise as a lifestyle habit, that actually would mitigate the buildup of senescent cells. So it won't completely, make it so we don't get any, but they'll develop slower. So, an older animal, an older human doing, appropriate exercise is going to have, at least in their muscle tissues, fewer, because that's where they've looked, right? But that doesn't mean maybe in their joints or somewhere else that exercise prevented or mitigated that buildup. That may, but science hasn't looked at that. And my guess is that it may a little bit, but it wouldn't completely offset it. So if it did, then one of the things you would see classically is that people that, use their joints a lot in their exercise, their joints have a degree of soreness and don't bounce back as well, even by often their 40s or 50s compared to when they were younger, right? So my guess is that exercise is really useful for slowing the buildup in muscle, but maybe not as much for other tissues, but net, like a huge positive.
Right.
I started the conversation saying something along the lines as, there's a range of doors that a stress cell can walk through, right? So, door number one is, and this gets into your idea of hormetic, right? Like, all right, well, the right amount of stress, which is going to be a low amount, and assuming a cell has the resources to respond appropriately, the cell will become more resilient, right? It'll be a hormetic thing, right? So we want that, right? We want our cells to be more resilient, tougher, right? Because just like us, they get stressed and they don't always expect it. And so if they're tougher, they'll, more of them will then stay healthy cells. And that, a bigger amount of stress, or stress that a cell might be unprepared for, then some damage will occur, right? So that's, the goal then is to do things to clean up that damage. So that's where autophagy comes in. And any of the things that we know now help with autophagy. I would default to thinking of those things as things that would prevent a cell from becoming senescent. So that's your, maybe saunas, maybe your periodic, like a fasting mimicking diet, or these other things. Calorie restriction, works maybe more on nutrient sensing pathways, but then, what often happens when a cell senses the environment is going to be more challenging is they prioritize surviving and repair over, growth and other things, right? So they hunker down and make it through. So my guess would be, as science does more studies on some of these diet and lifestyle things, that the biohacker community or functional medicine or the longevity community know how organisms live longer, healthier lives, will find that there's a connection to senescence. If that, I don't know if that answers your question, but
no, it does.
And conversely, we know, like when I said stress, the original, if you were trying to stress cells in a cell culture, you would, deprive them of nutrients, or, bombard them with radiation, or expose them to UV, or, make the environment harsh in some way. And we know that causes more cells to become senescent. And so, when I said, stress to certain amounts can cause that, think of, all of those types of physiological stressors to cells. But then, my intuition would be that stress writ large, like the mental, emotional, financial, caregiver, like this whole,
like the chronic daily stress contributors,
is going to likely be found, just like that's been linked to shortening of telomeres. I think we'll eventually find that that's linked to premature buildup. And like as an example, I know you have a lot of passion and knowledge about cancer. And so, cancer cells aren't senescent cells, completely different thing, but they would have in common that they're stressed cells, right? The senescent cells, they've been like zombified so that they can't make new copies and, grow and multiply and multiply. Cancer is the opposite, right? Like it's a very different outcome. But the thing they would have in common is they're both not going through apoptosis, right? And so, what a lot of the medical approach to cancer has been over time is to do something that creates a lot of stress that finally gets them like so stressed that they have no other choice but to go through apoptosis. So, that's your radiation or some chemotherapeutic drug. So, what science is starting to look at is, okay, these things were really big stressors. What happens to previously healthy cells? And what would be your guess?
I mean, I'm looking at like patients who go through chemotherapy, radiation, who perhaps might be older, and again, like their immune defenses aren't as strong. I'm assuming they're going to go on to develop more senescent cells from those therapies.
Yeah. So, so that's something that science is now starting to pay attention to, that because we did this thing, to get a good result, something we needed. But one of the downsides is that previously healthy cells, more of them became senescent. And so, what I'm starting to see on, studies in Pubmed, the medical database, is, thoughts of like, oh, maybe we should do a 2-step approach. And, at some period after chemo or radiation or whatever that therapy period has ceased, then we do something to help get rid of the senescent cells we created as part of that.
Yeah, exactly. So interesting. Well, I mean, it's encouraging to know that we can get rid of senescent cells, right? This is not something that, someone has to be afraid of, that, oh, they're going to have this indefinitely. And there certainly are, as we touched on, lifestyle interventions as well. Going to nutrition and diet, Dr. Kelly. So this is an area where I know many folks have very strong opinions. Has there been any research on the optimal diet from a standpoint of limiting senescent cells in the body?
There's nothing to do. The only things I've seen is connections to calorie restriction. That tends to, just because that has such a strong history of being connected to slowing aging. But my guess would be that, as senescent cells become easier to measure, because I'm at least optimistic that at some point there'll be some non-biopsy way figured out to get a better sense of their the body burden or tissue burden of senescent cells. Then those types of studies become more possible. But like as an example, stepping back, if we just say, all right, like brain health, like what diets are most strongly either correlated with or impact brain health as a cause and effect as we get older. And then that menu starts to, so Mediterranean diet will have been one of the more well-studied ones from a brain aging perspective. With people that already have have lost some cognitive function, keto diets become more important, for what I would think of as, a healthy functioning brain. So someone's, irrespective of age, they're not having memory issues. They're, able to have good focus. Keto is probably not going to matter. The brain, a big part of, when we think of, okay, what do we need for the brain to perform at its best? And this oversimplifies it, but, we need to protect our neurons and other things, right? So, protective things, but then it's about energy. So the brain is a voracious consumer of energy. We have basically, a hungry brain for energy. And the main energy source is glucose, right? Like a component of sugar. And then, as a backup, ketones, fat, things like that can be burned. But what often happens is that some people genetically aren't as good at burning glucose. Maybe at a young age, they start to have, more issues with, mood issues or other things. And often then keto will make a big difference in how their brain performs. They just didn't get the software package, so to speak, that allowed them to be as good burning glucose or sugar. Other people, not so much. And then, diet like the Mediterranean diet is going to have good oils, lots of antioxidants and protective compounds. So that's a good default one, but one that won't work for everyone. So
Right.
the key thing, this goes back to when I was a naturopathic student. I had a few different naturopathic professors that taught our nutrition classes at the time. And one of the things that I remember like really sunk in at the time, because at the time I was vegetarian. So if you had asked me this question then, I said, oh, everyone should be a vegetarian. But he said, oh, like I've done a whole bunch of diets. And when I do them hardcore. And I've worked with a lot of patients, and diet is the main, my main thing that I focus on. And the one thing I've learned over all these years, and this is him speaking and me paraphrasing, is that there can be a big difference between a diet that takes someone that's unhealthy and moves them to healthy, and then the diet that keeps them healthy. So, don't be as dogmatic, be more flexible, and pay attention to, is this really working for you? Right. So that would be the key thing for listeners, is experiment, but don't get attached to this way is the right way. It could be it's the right way for today, but maybe not going to be as useful come December of this year or spring of next year.
Yeah. No, I couldn't agree more. I mean, and that's another reason too, Dr. Kelly, why I really like wild health testing, for example, is because it also gives you the DNA component where, like, I, for example, found out I'm sensitive to saturated fats. And I found that reducing my red meat intake has actually helped me feel better. But had I not known that little bit of information, I may not have been, inclined to change my diet. So I think there certainly are, helpful information bits about our cells and our makeup that, can inform some of the lifestyle choices we make.
Oh, 100%. Yep. Yeah. And, so it's always important to pay attention to us, right? We're all biochemically somewhat unique. A good heuristic often is, what did my ancestors thrive on? Because, at least got them to reproduce, to the point of me. So we were talking, I grew up in the Boston area. Both of my parents have, like all of our ancestors on both sides came from Ireland. Right. So, so I feel well and metabolize potatoes really well, but I had at least, generations of my ancestors that were subsistence farmers that had to figure it out and live on potatoes, and probably, the genes of the people that most suited for that eventually made their way to me. But, someone that's, ancestry maybe is Japan, maybe not, right? Someone, and then like, I mentioned our health status can make a big difference. There's, like I have a naturopathic friend that does the Bredesen protocol and has, worked specifically with dementia patients. And, in her work, she would say, okay, keto's almost of every single thing I can do, keto may be the most important to get their brains just back, really thinking well again. And so it's just going to vary. Maybe, one of those people was Irish and would have done great on potatoes 30 years ago and not on the menu anymore. So
Yeah. We all change, right? Now, I love that. I couldn't agree more. We're coming up on time, but one other question I had for you, Dr. Kelly. So aside from some of these compounds like quercetin and whatnot, are there any drugs being studied right now when it comes to looking at reducing senescent cells? So, for example, I initially first heard of rapamycin as an anti-cancer agent. In fact, my mom was on a protocol of that along with metformin. She was doing some repurposed drugs for cancer. And then I started to do more research on it, and I heard that it actually has a lot of incredible anti-aging benefits as well. Again, when given in small doses. So what are your thoughts on rapamycin and its correlation to senescent cells?
So within think of there's a category called xenotherapeutics, right? Like things that would help manage senescent cells. One of them, the doors, is senolytics. And senolytics are things specifically that then help the cells go through that, apoptosis process. And senolytics are things that are typically given in a hit and run manner, meaning you would take them for a couple of days and then it'd be at some window that you don't take them. So that it's an intermittent strategy. Then there's other things that are thought of as xenomorphics. So what those tend to do would be they dampen down that inflammation that the senescent cells are sending out. So they're at least mitigating the zombie impact of creating new ones. And then there's the immune system. So things that support the immune system, if the immune system is, rejuvenated in a sense, it will do a better
Right.
job finding the lingering cells. So rapamycin fits somewhere between that immune and the xenomorphic, that managing inflammation thing.
Gotcha.
So, and it works like nutrient sensing. mTOR specifically is thought to be its main mechanism, but it's one, if not the only compound that. So when scientists study lifespan extension, they'll usually start in yeasts, then they'll move to like flies and worms, and eventually they move to mice, and maybe even then eventually to primates. Humans, it's just too long a study. So rapamycin is, I think, if not the only, one of the only that's actually shown lifespan extension in all of those organisms. So presumably that means it's doing it on something that's a conserved pathway, something that we would all share, that evolutionarily it's ancient. So rapamycin, because of that, is maybe the most used, compound in the longevity category by people that are doing their own self-experiments and are comfortable doing things in advance of science saying, yeah, this works in humans. So.
Yeah. So interesting. Yeah, I'm definitely looking forward to keeping abreast on that research. And one other thing too, Dr. Kelly, you mentioned intermittent dosing. So with Qualia Senolytic, how often does one take it? Is that something that's supposed to be taken indefinitely? How does that work?
Yeah, so the original work on senolytics by the Mayo and Scripps researchers it was dasatinib and quercetin, that original study I mentioned. They gave it intermittently. So they would give it for a couple of days and then take, say a week off or 2 weeks off. And so the reason they did that was twofold. One, dasatinib is a really powerful immune, potentially suppressor agent. So they thought, okay, well, let's give this instead of every day intermittently to maybe get some of the upside and prevent some of the downside. And so that was just kind of baked in from the beginning, was this idea of hit and run dosing, intermittent use. And so even with the natural compounds like fisetin, then that's been integrated in. Let's do a really large amount of this compound, but just do it for a couple of days and then take a vacation from it, and then we'll repeat. And so that vacation from it, that intermittent window varies in studies from, maybe it's 7 days, maybe it's a couple of weeks, maybe it's a month. And so that's what we do with Qualia Senolytic as well. So me personally, I take Qualia Senolytic the first weekend every month. I take, one dose on Saturday, one on Sunday, and then I don't think about it again until the next beginning of the month rolls around. In our studies to date, we've tended to bring people in that already have an issue. Often we've recruited people with joint issues because those are something that we know senescent cells contribute to, and that we can more directly study without having to do lab work. And in those studies, what we've seen is the best response happens when, instead of doing it once a month, we do it twice a month. So we take it for a weekend, don't take it until not that next weekend, but the following weekend. And then we'll do that for a few cycles and see if we can get someone's comfort levels with their joints way better, their flexibility improved. And the way that I would approach it is, once that comfort has improved, then you can maybe slow it down to once a month. Gotcha. And then in a younger person, if say someone was 35 and having no issues, but
that was my question.
Senolytics, then it's like, oh, well, you just need to be like a periodic gardener. So maybe once a quarter, like you would do an intermittent fast, do Senolytics just to prune away the ones so that you make sure you're staying comfortably below the threshold where they're causing any issues.
Right. Very interesting. Well, Dr. Kelly, this has been one of my favorite conversations to date. I just want you to know that you're such a wealth of information. I look forward to having you on again soon, because there's so much to talk about. But this is certainly an area that I'm really fascinated with, as you can probably tell. But with that, where can listeners find you and also learn more about Qualia Senolytics?
Yeah, we're qualialife.com. It's QUALIA Life, LIFE.com. And Instagram is where we're really prominent, sharing education and things. So I would say the best start is, either following us on Instagram or going to our site. I wrote, when we launched Qualia Senolytic, I wrote a long blog talking about senescent cells and, some of the senolytic compounds and why, as a company, we decided to make the product the way we did. We also have a studies part of our website. If you're, more inclined that way, you can, look at our senolytic study and see, what we saw, in our placebo study.
Awesome. Yeah, I follow Qualia's Instagram account. I absolutely love it. Some really great information on there. So I will be including the link for that and everything you mentioned in the show notes. But my last question for you, and this is my favorite one to ask, and that is, what does being well and strong mean to you?
Getting to live my life my way for as long as I'm alive. So I have always liked the idea of vagabonding, being like a digital nomad of sorts. And so
Love
for
that.
Listeners, I'm 62 now. By the time my dad was this age, he was a big guy. He struggled even to navigate airports comfortably. And I want to still be flexible to do yoga, able to travel several decades into my future from here. So that's what it means. Like I think what's important to you, to me, to other listeners is going to be somewhat different, but I want as many people to be able to do what brings them joy and purpose for as many of their years as we can help them get to.
Love that. Amen. Couldn't agree more. Well, Dr. Kelly, thank you so much for your time. I'm really looking forward to sharing this with listeners, and yeah, I hope to have you on again at some point soon.
Yeah, I would love that. Maybe we could talk about the brain in the future.
Absolutely. So many topics.